Hello everyone, today's video is going to be a very special video because in this video I'll be telling you some secrets of software engineering. How do you write big answers by remembering as less as possible, and how do you use the three magic words what, when and how to expand the theories, and how do you remember the key points, and how do you use the synonyms to expand the same concepts again and again in different questions. Okay, so all these things will be discussed. Make sure you watch the video till the end, and before starting hit the like button and subscribe to my channel for more videos like this. And in this video we have 16 questions which will be discussed, and these questions are more than enough for you to score more than 80% marks. Okay, so without wasting any more time, let's get started. The first question is define software engineering. Okay, and explain the practices involved in software engineering. Now you have common sense, right? Do you have a common sense? Yes, obviously you do have a common sense. So you know English, right? What is software, what is engineering? Both of the terms we are well aware of that. Okay, so the same thing you have to write it in your own words. What is software engineering? It is a branch associated with development of software. We are doing software engineering, that's why we'll develop that's why we'll develop software, right? We are not doing hardware engineering, right? So you'll have to write the same thing here. Developing the software. How do you develop it? Using well defined scientific principles, methods and procedures. By using the principal methods and procedures, you'll be developing a software that is called as software engineering. And by using that, what you are actually getting, the outcome will be getting an efficient and reliable software product. Okay, this is the definition you need to write. Next is, what are the practices involved in software engineering? Now this question you'll remember it like this. Okay, practice. To practice something you need energy. To get energy you will eat some food. Okay, what do you like? You like a pastry or a cake, right? So to make a cake, okay, to make a cake, first what you require, you require the ingredients, right? You require the ingredients to make the cake. Once you have the ingredients, you'll imagine what kind of cake you want to make. Okay, that kind design you will be imagining. Okay, and after you have designed it, means imagine the design, you'll start to make it. Okay, you'll start to make the cake, putting all the ingredients and making the cake. Now after you have made the cake, you will taste it, right? Tasting it and telling if it is good or not. If it is good, you will save that recipe in your recipe book. Okay, you'll save that recipe in your recipe book. After that, you'll be able to manage that recipe whenever you want. If you want to make some changes or you want to update it with some new recipe or so on. Okay, that is the last thing. Now the same thing you have to relate it with the 6 key practices in software engineering. First, imagine yourself as a chef and you are making the cake. You want the ingredients, so requirement analysis. Second is, after you have the analysis, you will be designing it. Okay, so system design. Next is coding. Instead of cooking, you will be doing coding here. Okay, after that, instead of tasting, you will be testing it. Okay, and you will be saving your recipe, so it will be documentation, and after that you will be managing it and making some changes, or if anything failures they will be handling it. If taste is not good, you will be making changes to the recipe. That is called as project management. These things you have to write. After you have written this one, you will be translating it into the world of software engineering. Now what is the requirement analysis in software engineering? These are the key points. Requirement analysis means you'll be understanding, defining the stakeholders needs. Okay, what is required to make that project. Okay, and system design means you'll be analyzing it, implementing and ensuring that whatever the design is there, that is satisfying the requirements. Okay, coding is nothing but coding it, and you'll be able to execute it, and you'll be able to translate the functionality requirements to actual software. This is the main part where the actual product will be formed. Okay, that is the making of the product. Okay, after that, after you have made the product, you'll be testing it for what? Testing it if it is failing or not, if the load is more, is it working or not, and is it applicable for large number of users, is it scalable or not. Okay, and what is the performance of it. Okay, so the best practices you have used or not. After that, you will be documenting all of them and keeping it for reference purpose in the future. Okay, and if any error comes, you'll be debugging it, and you'll be communicating the requirements and the reports to the other team members. And project management will include all those things. You will be validating it and you'll be maintaining it, and if any changes are required, again you will be starting from here, requirement analysis, and doing the whole same things. Okay, so these are the key points you need to write in the answer sheet. Now you have to use 3 magic words. Okay, in the top of this I have mentioned the 3 magic words, which is what, why and how. Okay, plus synonyms. You need to know a lot of synonyms. For one word, how many different words can you write? Okay, that you need to know. And for each key point you have to do the same thing: what, why and how. What does this mean is, for example, if we take the example of requirement analysis, what is requirement analysis? First write that in the answer sheet. Okay, what is requirement analysis? Okay, why is requirement analysis required? What will happen if requirement is not done? We will be able to get a product, but that will be of no use, right? That same thing you have to write here. And how we will be analyzing the requirements? That analysis will be done based on research, based on asking the other people, expert consultancies, and historical data. By using all these things, you'll be able to analyze and get it. Okay, this all answers, you know, in your brain. It is there. It is a common sense. Okay, you need not learn it to by heart it and so other things. These all things, you know, it is common sense. Okay, just imagine yourself as a real world software developer. If you want to do the requirement analysis, what you will do? You'll search in Google and do all those things, right? Same thing, you just have to write in the theory and include these keywords so that you can expect maximum marks. Okay, moving on to the second super important question, which is compare and contrast waterfall model and spiral model. First thing you need to do is make this model here. Very simple model. 5 steps are there. First is communication. That includes project initiation and requirements gathering. You will be discussing with your project members and the stakeholders or the customers what is required. Okay, that you will be communicating and getting to know. After you have got all the requirements, you will be planning how this can be done. Okay, after that you will be modeling, like in which flow we will be going, what all we will be doing, first, second, third sequence you will be designing. Okay, after that you will be doing the construction, which includes the coding part and testing part. After that you will be deploying it, delivery, support, and feedback. If any issue the customer faces, how you will be resolving it. Okay, that is the waterfall model, and here it is happening stage by stage. Once communication is happened and move to planning, we cannot move back. That is waterfall model. Okay, spiral model also the same things happen: communication, planning, modeling, construction, and deployment. But again it will repeat. Okay, once we have done all these stages, again we will repeat and do all these stages if any changes are there. So it is a flexible model because always different changes come in the real world, so we'll be able to make those changes included in the project by spiral model. So the latest models use spiral model. Okay, latest software projects. The difference between waterfall and spiral model: first is process flow. It is linear and sequential. Once you move to the next phase, you cannot move back to the previous phase, and each phase must be completed before moving to the next. Here it is iterative and disk driven. You can repeat the cycles and go back to the previous stages also. Flexibility: it is rigid, can't make any changes. It is flexible, we can make the changes. Risk is minimal here because once the stage is complete, then only you're moving on to the next stage, so risk is minimal. Here high risk is there because continuously different updates are coming in. Okay, so you need to be very sharp minded what changes you're including. Use cases: it is used for small well defined project. Okay, a small project is there, waterfall model can be used and completed. If big project is there, there will be complex requirements and you need to have means the changing requirements will be there, it will be more complex. Okay, and customer involvement: it is limited because customer once set the requirements, customer will go, and once the project is complete, then only you'll call the customer. But here customer is required and involved throughout the multiple iterations for feedback and validation. Okay, that is the spiral model. Moving on to the third question, which is explain unique nature of web apps. Okay, what is a web app? Just imagine a web app in your mind. Okay, imagine Facebook. Facebook is a web app. Now, Facebook, there are 9 unique aspects in nature of web apps. Divide the 9 into 3 parts. Okay, first is Facebook is used by a large network of people. Okay, and it is same time they are using, so there will be a very heavy load. These 3 keywords you got to know. Large network of people are using it, and same time they are using it, and there is heavy load. Based on all this, the Facebook is getting a lot of data, and the data is content sensitive. Okay, and by implementing the content and the people which are using, these two together give us the performance results, how well it is performing, is it available when it is needed, and is it latest updates are present or not, and is it quick and fast or not. Okay, so these things you will have to write the keywords first with this same example. After that, the key points will be as follows. Okay, so large network is there, so what are the needs of the people? Is there the client's requirement getting satisfied in the large network or not? What is the usage, same time they are using, and limited access is there or everyone can use? Because of heavy load, it is failing or not. Okay, and database communication is able to happen or not, same time they are using. Large number of users, what are the magnitude, waiting for long period of time. All these things come under the database and content sensitive. Then we have the performance, availability, latest update, and quick and fast. Okay, so poor performance or low performance or high performance, efficient or not, reliable, popular, aesthetic, what are the UI design of it, and latest update means we have the latest information which is needed in the web app or not. Okay, and the latest requirements are being satisfied in the app or not. And last is quick and fast, whenever a change is required, that change is integrated in this one very fast and it is released in the market, or it takes more time, is it evolving or not. and the market value what is there, is it maintained or not. Okay, these things you have to write in the web apps. So how you will be doing all of this is that each thing you'll be writing. Okay, large network. Suppose that you wrote here large network. You'll be first defining what is large network and why is large network required for web apps and how it is implemented. Large network, how it is handled. Okay, these three things if you write using these keywords which is present here, you'll be able to easily fill a lot of space in the answer sheet for this question, and you can expect the full marks here. Okay, also observe the marks, some where it will be 5 marks, 8 marks, 10 marks. Based on that you have to write that much content. Okay, next is discuss David Hooker's 7 principles of software engineering practice. Okay, so 7 principles easily you can remember. So see here, whenever you get to hear the term software engineering practice, what you have to remember is you are a software developer and you want to develop some project. Okay, so first, as a software developer, what reason you have to develop a software project? The reason is to make a lot of money. How you will make a money? See, the reason you have to make a lot of money, so you fall in love with the reason so much that you will kiss the reason. Okay, so after you kiss the reason, you will start realizing that I have a vision by which I can make more money. How you will make that? You will code an app and you will be selling it to the customers, so that produce and consume will happen. You will be producing an app and the consumers will consume an app. They'll pay you for the app and you'll have a lot of money. Okay, once you have a lot of money, you will be starting to imagine the future. Okay, in future how much money I will be having. Okay, and you want to make more money. To make more money you have to write more code, but you have a trick in your mind. You will reuse the existing code and you will again sell it to the customers, and the customers won't know. Again they will purchase it from you and you will make more money. Okay, but you need to be very careful. Think before whatever you do, you have to be not doing illegal activities, otherwise everything will be undone. Okay, so reason is vision, produce, consume, future, reuse, thing. Okay, now what is reason? Reason means it should be providing value to the users. Whatever you are developing, software engineering practice, it should provide values to the user. KISS means keep it simple stupid. Okay, means you have to keep the product simple. Everyone should be able to understand the product. Okay, vision means what you have decided first, why you started making the project, what was your initial goal, ultimate goal. Don't deviate from it. So if you deviate, what will happen? You had planned something and some other product will be built at the end. Okay, that is useless thing. Next is produce and consume. If you produce value product, you will get money. If you produce garbage, you will get what? Garbage. Okay, future, always update. Always think about what updates can come in future. Okay, that's what it actually means. Always be open to the changes. Reuse means reuse saves time. If you have a code which already works for some scenario, and by slightly changing it you can make it work for this scenario also, just use it. Okay, so think before you act. Whatever you make the decision, think a lot before you are executing it. Okay, these are the key points you have to write. Again the same thing, the key points like this you'll write, and for each of them what, why, and how. Okay, if you think, you'll get to know a lot of content in your mind. Okay, so those same things you have to write for the software engineering practices. Okay, 7 principles. Moving on to the module 2, we have how can you develop effective use case. Okay, and develop a UML use case for the home security function. Okay, this is very much repeated question, home security function. Now whenever you get to know a use case, what you have to remember is you went to a shop and ate a samosa. Okay, you eating samosa. Okay, these keywords you have to remember, you eating samosa. Okay, now that is a use case. Okay, you eating samosa is a use case. Okay, now what are the guidelines you need to follow to develop an effective use case? In you eating samosa, who is eating samosa? You are eating samosa, so the actors who are involved, who are doing the activities, that are the actors. Okay, and goal, what is your goal? To eat samosa, that is your goal, right? And the flow, what is the flow? You went to the market, then ate samosa, that is the flow. Okay, alternative flow, instead of eating you could have packed it in your bag, right? That is the alternative flow. Pre and post conditions. Pre means you had hungry, you were hungry, you ate a samosa, and then you are full, you are not hungry anymore. Review means after eating the samosa, review how much weight you have gained. Okay, so actors, goal, flow, alternative flow, pre, post condition, and review. Now in exam, what you have to write for each of these? The key points are users, component, and external system. These are the actors. Actors means who are involved. The users are involved in some scenario, and the components are involved, and the external system is involved. Okay, and goal, what is your goal? Goal is what to achieve, specific, achievable, measurable, and achievable goals. Okay, those all things come under the goals. Whatever you are defining, that should be specific, achievable, and measurable. Next is flow. What are the sequence, what are the actions, what are the tasks, activities being performed? Okay, and what are its effects after you perform that task? What will be the effect? Alternative flow means in case any different condition comes, if edge cases comes, failure, backup comes, what you will be doing, that is the alternative flow. And use case before and after. Before and after means before how it was and after how it was, the scenario, that is pre post conditions. Okay, and defining stakeholders and revise means you will be reviewing the plan with the stakeholders. What plan? Use case plan, effective use case plan, you'll be reviewing with the stakeholders, and if any changes is required, you'll be revising it. Okay, so the UML use case diagram for home security function is as follows. First, make two entities here, homeowner and system admin. What you will make? Homeowner and system admin. After that, homeowner can arm or disarm the system, means switch on or switch off what are the components present in the system, and access the system via internet. By internet, they can access and control what is to be on or off. Okay, and if any alarm or this urgent event happens, they will be responding to it, and if an error condition comes, they will be making those contact to the system administrator that error has come. Okay, what does system admin do? They will reconfigure sensors and related system features. They will be ensuring that it is working properly. That is the system administrator. And sensors will have access to the alarm events and error conditions and whatever the reconfigurations is being done. Okay. So what you have to write in the theory. In theory, you have to write the same thing. First, you have to write this as homeowner you arms disarm system. Okay, that you have to write here. After that, you will be explaining it. I'll give an example how we can explain it. Okay. See, homeowner arms and disarm system. Think a lot. Okay, in software engineering you have to think a lot. Think, what is arm, what is disarm, what is system? System means the whole home. They have asked about the home security. To make the home secure, what all you will do? You will install the locks, you will install the CCTV cameras, you will install sensors if some events are happening, you will install the fire detection, means that sensor, that kind of sensor. All the other things you'll be installing and you'll be making sure that the home is secure. Okay, arming and disarming means you will be switching on or switching on or switching off all of these. Okay, that can include the air conditioners, refrigerator, heater, light, fan, all those things. Okay, you are having all the control of arming and disarming the system. Okay, and again here also you'll apply what is arming, disarming, and why it is needed, and how you can implement it. Okay, how you can implement it using the softwares and the sensors. You'll be able to implement it, and you'll be connecting it with your mobile via the internet. You'll be downloading an app which will connect all of these, and you'll be defining who can access and who cannot access your app and control the app, make changes. All those things you'll be filling in the answer sheet. Think a lot, and you'll be getting a lot of content. Okay, believe me, you already know all of this is just common sense. Okay, nothing new. This all things we have seen in the real world. The same thing you have to write in the use cases also. Cool. Moving on to the next question, explain negotiating requirement and validating requirements. Before that, understand what is negotiation. Negotiation means meet the requirements and real world needs. And validation means inconsistencies, losses, use cases, details, and so in negotiation, what all you requires? You requires a win-win situation. Win-win situation means suppose that you went to buy chips, okay, and the seller is selling chips for 15 rupees and you want it for 10 rupees, okay. Then you tell the seller that this chips is available in the market everywhere at 10 rupees. So please give me a 10 rupees. So he will give you a 10 rupees, okay. So he has made money, he has made a profit on 10 rupees as well, and you have got the chips in what rate you wanted. So that is negotiation. Win-win situation. He got the money and made profit, and you got the chips for a cheaper price. Okay, so what are the steps to be followed in negotiating and validating requirements? Okay, identify the stakeholders, who all are there in the system. Okay, means who all are interested in the app. Okay, suppose that you are making an app or a project, who all are interested in the project and who is paying money for it. Okay, that is called as stakeholders. Identify who all are there, identify their win conditions, means in what price they are able to pay it, and reconcile with your conditions whether you are able to make it in the same price which they are telling or not. If not, make some negotiations and change it. Oh, yeah, that is a negotiation, negotiating requirements. Next is validation requirements. After the negotiation, we'll go through these things. Okay, is it consistent overall? Is there any inconsistencies in between or errors are there? Is it specified at proper levels, all the things which are going to be done, actions, activities are specified at the proper levels or not, and only the important requirements are there. The useless products, useless requirements are removed or not. No ambiguity, doubt, or unclear. There should be no ambiguity. Everything should be crystal clear. These things you'll be verifying, and if it is done, you'll be starting the creation of. You'll be developing the project. Okay, that was about the negotiation and validation requirement. Moving on, we have the next question. Provide a brief overview of key tasks involved in requirement engineering. Okay. Here, what you will remember is in requirement engineering, requirement means what? Requirement means what all the things are needed. For that, you need to do a lot of research. Okay. Research means R&D, research and development. Research and development only those people do, those who are experts. Okay. So you want to become an expert. This is the story you need to remember. Requirements engineering is R&D, and R&D is performed by experts, and you want to become an expert, but you have self doubt that you will be able to reach expert level or not. Okay, for that what you have to remember is I eventually entered next stage validating myself. Means requirements analysis is the next stage which only expert people can do, and you're standing at a lower stage, but you made it to the next stage by validating yourself, that having a self belief that by having a self belief that you can reach the next stage. Okay, so this thing you have to remember, IEENSVM. Okay, write it in the top part of your answer sheet wherever you want. Okay, after you have written this one, then you have to elaborate this one. I means what? Inception. In requirement engineering, first you have to do the inception. Inception means understanding what is the requirement. Okay, understanding what is the requirement by communicating with the team members and gathering information, researching and listening to the team members requirements. All those things you will do and understand what is the requirements. After that you will elicit means extracting information. You have just got the key points. Now you will extract that information. What does all of this actually mean? From different resources you will get to know the information. Okay, that is elicitation. Elaboration means whatever that information is there, you will be adding more details to it. Okay, next is negotiation. You'll be forming a win-win situation with the clients and stakeholders. Specification means making it clear whatever the requirements are there. That should be crystal clear. Everyone should be able to understand it. Validating the requirements and managing the requirements. If any changes are needed to be done, how you can implement the changes here. Okay, these are the things you want to explain in the task involved in requirements engineering. Okay, just imagine a use case scenario. Suppose you are developing an application software for connecting two or more people. For that the requirements are present here, how you will be implementing it. Okay, if someone tells you to implement it, they'll give you $10,000. At that case, what all you will do, how you will understand the product, what all information you will ask, all those things you have to write. And remember the three magic words: what, why and how. Okay, for all of this, how you will, what is understanding and why you will understand it and how you will understand it. For that, all of this you'll be doing and writing it in key points. Okay, like that you'll be filling the page. Okay, moving on to the next question, we have explain requirements elicitation. Elicitation means gathering. Okay, gathering the requirements. How do we gather the requirements? Remember the example of home security function. In home security function, we will be first identifying who are the stakeholders, means the people or the groups involved. Okay, who are the people or the groups involved. Next we'll understand what is the goal. Okay, first we have got to know who are involved and what do these people want. We'll ask them what do you want. Okay, so we'll clarify the purpose of the system, and then we'll collect information about the requirements, and then we'll document it. Okay, we'll be documenting the requirements and keeping it at a safe place, and then we'll be validating it and prioritizing requirements, which is the most important requirement and which is valid and invalid requirements. That we'll be doing based on accountability, feasibility and business needs. Okay, so these are the 5 steps in requirement solicitation. Okay, the same thing you have to remember for the home security function. Okay, and examples also you have to write. Okay, then after that it can be carried out in collaborative ways. That include, see, all of these things can be done by using the by conducting interviews, workshops and providing the surveys and questionnaires, observing by watching the users perform their tasks, and prototyping it. Prototyping means creating models of it and observing if it is working or not, and use case and scenarios based on this will be defining the requirements. Okay, so these things by using these methods will be doing the requirement elicitation or requirements gathering in these 5 steps. Okay, Moving on to the third module, the first question is explain the agile process and its principles. For agile, what you have to remember, agile means moving fast, changing, okay, like that. So for this you have to remember a cricket player. A cricket player will move very fast, hit runs, and take wickets, and field it, catch it, and save sixes and fours. So all those things, very fast changes will be there, okay. That is agile process. It is a flexible and iterative. What it is, it is a flexible and iterative, repeat with me, it is flexible and iterative approach to software development, okay, that develops in short spans of time called cycles or sprints. There will be one cycle, second cycle, third cycle, fourth cycle. It will be developing little and so on, okay. So that is called as agile process. It's flexible and iterative, okay. It will repeat, that's why it is iterative. Next is agile principles. So agile principle, you have to remember one keyword. There is chaos. Chaos means in cricket field everyone is shouting and supporting their players and making a lot of noises, but you find peace in between all of these by keeping a mindset clean, by keeping your mindset focused and clear, okay. So after remembering this, what you have to do is, firstly, you have a friend. You have a friend who is a cricketer and he is not performing well, okay, he's performing very badly. So you'll ask him why you are performing badly. He'll say that I'm not satisfied with myself, maybe I'm not that good. So you motivate him, okay. After you motivate him, he'll start to change and he will make a lot of runs, okay. So satisfy, okay, this is what you'll do to your friend. You'll satisfy your friend that you are good, you are better, you will be able to perform it, you will crack it, so that he will start changing and he will start delivering the runs. And once he delivers the runs, he will be happy and everyone will be together with him and they will be motivated, and he will have face-to-face conversations with them. After that, he will get a notification in his phone. What he will get, he'll get a notification in his phone about the product he is developing, okay. He's also a software developer, okay. So he's developing a product which is usable, sustainable and excellent, okay. Whatever he's developing, it is usable, sustainable and excellent, and it is simple, okay. Now then he will realize how it is usable, sustainable, excellent and simple. It is because the team is self-organizing, means all of them work together in a good organization, and they'll self-correct. Self-correct means whenever the mistakes happen, so they will correct themselves and always try for improvements and goodness, okay. So at the end of the day, he will be happy, okay. During sunset, he will be happy. So the same thing you have to write. Now after you have written the keywords, you have to translate the keywords into actual meaning, okay. Here agility principles, in agility principles you have to follow some practices, okay. You have to always satisfy the customer's need has to be satisfied, that is the first priority. And you have to always welcome the changing requirements. See, the world is changing, the requirements will also change. When it comes, you have to incorporate the changes in your system, okay. That is called as changing here. And delivering whatever the requirements are there in proper time, okay. And be together with the team and be with the motivated people. Always have face-to-face conversations whenever you are discussing something. That will not cause ambiguity. You said something and they understood something, that will be reduced when you have face-to-face conversations, okay. And the product which you made should be usable, sustainable, excellent and simple, okay. And always encourage self-organizing and self-correction teams, okay. That one you have to write. For each word you have to write here and explain it by using the three magic words: what, why and how, okay. Next is elucidate the concepts of extreme programming, which is functional diagram. Now, what is extreme programming? Extreme programming is a subset of agile programming. Okay, this is also agile programming where there will be having many changes happening here and there. But here, a specific thing will be there. It aims to improve the software quality. Okay, it aims to improve the software quality and responds to changing requirements. When a requirement change has come, it will respond to it very well. Okay, through a set of well-defined practices. Now the diagram is like this. How you remember this diagram? Okay, first is planning, okay. You will be planning something, and based on that plan you will be designing it. After the design you will be actually coding it and testing if it is working or not, and again you will repeat for the new plan, again design, code and test, okay. It's pretty simple. Looking at once only you can get to know it in your mind, okay. So in planning you have user stories, values, acceptance criteria, iteration plan and so on, okay. So the key points of each of these is as follows. The first one is the planning. Okay. So in planning, what we have is the first is listening. Okay. In order to plan something, you have to listen to all the people what they are telling, so that you'll get to know the requirements. You'll understand it, and you will be deciding what is to be done based on what conditions are present. If there is any conditions, they require this, they require that. How you'll be reconciling that? Or based on that, you'll be making a plan, and you'll be using the user stories, values, acceptance criteria, and iteration plan. Once you have planned it, you'll be designing it. How do you design it? By using CRC cards. Okay. So the keywords are it should be simple. Whatever the design you have made, it should be understandable and clear. Okay, and the functionality which is planned, that should be implemented in this design. After that, you will be starting to code. In code, you'll be first writing the unit test cases for checking if the requirements are able to code or not. And after that, you will also be the XP encourages pair programming. Okay, pair programming means two or more people will be programming in a same for the same project, okay, together. Okay, based on that, the outcome will be more better. Okay, because two people are involved. And use cases and efficiency. Okay, it should have the satisfy the use cases, and the code should be efficient. Lastly, after writing the code, you will do the test using the unit test cases, validate it, and for the edge cases you will check for the rare cases, and if it is accepting or failing, and in the time constraint this is happening or not, that you will be testing. Okay, moving on to the module 4, we have describe project management life cycle. Okay, till now we knew about the software development lifecycle. This is what project management lifecycle. Okay, let's revise what is software development lifecycle. In software development, first we will analyze the requirements, design it, develop it, test and deliver it. Okay, in all of these phases there is a manager who is managing all of this, right? They are checking if the project is working properly or not. In each phase the requirements are being done in proper phase or not, coding has been done properly or not, and the closing phase delivery is done properly or not. So they are managing it. And the managing phase starts before the developing phase, because first you need to plan what is to be made. Okay, that is a managing phase, initiation phase. Okay, so the project management manager carries out the project initiation, planning, execution, monitoring and controlling, and closing. Okay, so this is a diagram you have to make: project management lifecycle and software development lifecycle. This is optional, but you have to make this one: initiation phase, planning phase, executing phase and closing phase. In each of these phase the following points come. Okay, project initiation: how you'll start a project, what is the concept you want to make a project, you'll do a study on it, the characteristics you'll get to know, the requirement, goal, feasibility, business case, all these things include in the project initiation. Okay, and planning: how you will do it, document it, what is the flow, what are the tasks and activities, the diagrams for depicting the same, and resources and time used. Okay, execution includes code, implementation, functionality, use case, working model, and monitoring and control includes maintenance. Mainly it is maintenance. Okay, and development: if there is failure, how you will fix it, what is the quality and validation. All these come under monitoring and controlling. Okay, and closing: you will be exiting the project. Document will be made properly, and it should be clear between the two parties whether the project is delivered properly or not. Analyze the performance and agree to the terms and conditions, and release the project for the use by the public. Okay, so these are the 5 phases and the key points you need to use for project development, project management life cycle. Okay, next is explain project risk evaluation. How do you evaluate a risk? Okay, for the risk, you imagine the NASA has told that one meteor is coming and hitting the earth. Okay, so that is a risk, right? So project risk evaluation is a process of analyzing the risk. Firstly you will identify the risk. Okay, first you will get to know if it's actually a risk or not. If it is actually a risk, what is the probability of the meteor hitting the earth, that you will calculate. And if it hits the earth, who all will be impacted and how severely they will be impacted. Based on that you will be categorizing the consequences based on the highest effect and lowest effect, and different categories: if it is harming the environment, if it's harming the people, if it's harming the finances, and so on. Okay, so all those things you will be involved in this one. The same example you have to remember: identify, probability, calculate, what is the impact and severity, categorize and prioritize. Okay, the key points are given below. Identify the risk, list, brainstorm, historical data, expert consultation. By doing all this, we'll get to know what is the risk. Then calculate the risk based on the formulas. And risk impact: what will be the consequences. It can be either the timeline delay in a project, since we are considering the project, since we are talking about the project. If there is a risk in a project, the timeline can be delayed, or the budget can be overrun, and the quality could be reduced, or the reputation can be affected. Risk severity means impact plus probability. Impact and probability, when they are combined, the severity will be calculated by using a formula. Okay, characterize and prioritize: the characterize the risk into the different groups, what kind of groups, the risk it is. Okay, and prioritize which is the most high risk, and which is the medium and low risk. Okay, and for that we can use the tools risk matrix and heap, and if there is a risk, how we can solve it using some actions or methods. Okay, that also will be discussed in the characterize and prioritize. Okay, so these are the things which will be the steps and the project risk evaluation methods. Okay, Moving on to the next question, which is explained with example different categories of software projects. Okay, very interesting question. First is voluntary and computing compulsory users. Okay, voluntary means my wish. Okay, by my wish I'm using it. For example, recording a sale. If a sale happens, I'm recording it. If it does not happen, I'll not record it. And playing a game. Whenever I want to play, I'll play. When I don't want to play, I don't want to play. So voluntary. Okay, based on our wish. That kind of projects are called as voluntary user projects. Okay, and second is compulsory users, means monitoring CCTV footage. There will be a system admin who will be always monitoring the CCTV footage. It is a compulsory project. It cannot be off sometimes and on sometimes. It will be always on 24/7. Okay, next categorization is information system versus embedded system. Information system will give us what? Common sense, it will give us information. So system could be stock control system, where it will provide the information about that system. Next is the embedded system. Embedded system will always control the machines and the products. Okay, so it is air conditioning system. So there will be a remote which will be controlling the air condition. So that is called as embedded system. Okay, next is outsourced versus conventional project. Outsource means you are doing the projects from some other place. Okay, you have divided the project into different parts, and each of these parts is performed by different teams. That is called as outsourcing. An example will be Indian software companies excel in executing outsourced projects. So we make the projects for the USA, UK, and so on, right? So they are outsourcing the projects from India. Okay, that is the example for outsourced project. Conventional project is the one which is made by a single company without outsourcing it from different places. Next is object driven development. Here we have produce a project or meet objective. There can be two kinds of project, either to produce a project requested by a client or to meet objective. Okay, so example will be project created based on the details specified by a client. A client will specify some details, that is the producing project. And if an organization is require have a problem and they require a solution, that will be a meeting objective require project. Okay, these are the four things you have to write. Voluntary versus compulsory, information versus embedded, outsource versus conventional, and produce project versus meet objective project. Okay, moving on to the next important question, which is elucidate the concepts involved in activity planning in software project management. Okay, so activity planning means what? You have to perform an activity. How you will perform that activity, that plan is called as activity planning. So activity planning in software project management involves identifying, scheduling, and managing. Three things are there: identify the thing which is to be done, schedule it when it is to be done, and manage it if it is being done properly or not. The task and activities referred to complete software project. Okay, so key concepts here are: if you have a plan and activity and you have to make a plan for it, you have an activity, you have to make a plan for it. Break down the project into different activities. Okay, first break down the project. After you have broken down the project, calculate if they are dependent or not, means this task is dependent on this task or not. Task B can start only when task A is done, whether that scenarios are there or not. After you have done that, estimate how much effort, duration, and resources are required. Then after you have got to know all this information, set milestones. In 10 days I will do this much percent of the project, in 20 days I will do this much percent of the other project, in 30 days project will be minimally usable. Like that, you will be defining the milestones and deliverables. In that milestone deliverables, there can be some activities which can take a lot of time. That is critical part analysis. In critical part analysis, identify the longest sequence of tasks to avoid delays. How we can handle this more time consuming task effectively, that will be analyzing. After that, we will be also analyzing the risks associated with that, and scheduling when it is to be developed, and monitoring and control is always there, and communication coordination between the team members. These are the key concepts required in the activity planning. Okay, moving on to the module 5. The first important question is define software quality. Again, common sense. You know what is software, you know what is quality. Just mix both of them and write the definition. It refers to the degree to which software meets its specified requirements. If software claims that it will do this, whether it is able to do this or not, and to what level it is able to do, that is called as software quality. Okay, and the place of software quality in project management is the next question. Where software quality is present in the project management? It is present in all the stages, but it is particularly more important in the four stages. in 5 stages, which is step 1. Step 1 is when you identify the project or the scope and the objective. When you identify what you have to do, okay, what is the project, and scope means how much things it will cover. When you are identifying those things, the quality is important. Next is when you are defining the identifying the project infrastructures. What will be the structure of the project, how well it is organized, that time you will be making use of quality. After that, what are the characteristics of projects, it should meet the quality characteristics, okay. And after that, identify the product and activities of the project. To make that project, what are the activities that are going to be performed, and by using those activities you will be creating a product. What will be that product, it should all be of quality things, okay. Finally, review and publicize plan. When you review back the all the things which are being performed, they should meet the quality standards, okay. And publicize the plan means share the plan with your teammates, okay. So in these spaces, the quality is of utmost importance, okay. That is the place of software quality in project management. 5 steps are there, okay. In 5 steps it is most required. Moving on to the last super important question of the SEPM, explain software quality models. Okay, it's for 8 mark question. There are 4 software quality models. First is McCall's models, Dromy's model, Boehm's model, and Garvin's model. Okay, easily you can remember each of these. Let's discuss. So firstly, McCall's model. Okay, it defines 3 characteristics. First is operational, what all it does. Okay. Second is how easy it is to fix the defects, maintainability. Third is how we can port it to different platforms. If I have developed in iOS, how I can use it in Android. That thing. Okay. Firstly, what it does, which is operational, and if any error comes, how it can fix it. And third is using in different products. Okay, these 3 characteristics. Okay, you got to know these 3 characteristics. Then you have to make this diagram. The diagram is optional, but it's helpful for remembering. First is product operations. Whenever you imagine a product, what do you expect of it? It should be correct, right? It should not be showing the wrong data, and it should be reliable. When you want to use it, you should be able to use it, right? It should not just switch off suddenly. It should be efficient. It should not consume more battery. Integrity should be there. All the things should be performed together effectively, and usability should be there. Your use cases should be satisfied with the product. Okay, so the product operations are there. If any error comes, you have to maintain it flexible to change it and test for the errors. That is product revision. And third one is transition, means using it in different platform. Portability, interoperability means again using with different systems. Reusability means you have if you want to make a new product, you can use the previous code itself for making the new product, okay, with some changes. This is all that I think 12 are there. This you have to write for the McCall's model, okay. You have to write the keyword and explain what, why, and how for each of these. So yeah. Next is Dromy's model. In Dromy's model, again three things. In Dromy's model, 4 things are there. So in the McCall's model, 3 things are there. In Dromy's model, 4 things are there. 4 things is correctness, internal and contextual characteristics, and descriptive properties. Okay. So 4 keywords easily you can remember: correctness, internal, contextual, descriptive. Repeat with me: correctness, internal, contextual, and descriptive. Now you have to first write quality here, okay. Then you'll write correctness, internal, contextual, and descriptive. Correctness means what? It should be functionable and reliable. That is what correctness means, right? Internal means it should be maintainability and reliability and efficiency. See, some keywords are there, just remember that: maintainability, reliability, reusability, and portability, okay. So these 4 keywords write in any order anywhere, okay. That doesn't matter, you can write anywhere, any order. Maintainability write in these 3, reliability write in first 3, reusability write in last 3, portability write in last 2, efficiency here, efficiency you write here also, usability you write here also. It doesn't matter, okay. Just have to fill the answer sheets. Cool. Now that is the Dromy's model, okay. Next is Boehm's model. It is defined again on 3 high-level quality characteristics. As is utility. As is means what? How well it can be used. Second is maintainability. How easy it is to understand and change it. Okay. Portability. How it can be used in different environments. This is common in all of the models. Okay. Portability. As is means how well it can be used, and maintain means how it can be changed if any change is required. Okay. So the diagram is very big, but there is a simple secret in which you can use to remember this diagram very easily, okay. First write quality here. What you will write? Quality, okay. Next you will write these 3 things: as is suitability, which means how well it can be used; maintainability means how easily it is to understand and change; portability means how it can be used in different environments and how difficult it is to change the environment, okay. So write these 3 things: as is utility, portability, and maintainability. Again, I'm repeating, you need not remember all of the keywords present here. You just need to understand what it means and write the synonyms in your own words. Write whatever you want, okay. But try to not remember all of these, then you will forget everything, okay. You have to just understand it and write in your own words, okay. If you put too much pressure on your brain, you'll forget whatever you have learned, okay. So stay cool. These all things are common English, you all already know all of this. Okay, you just have to know what it is specifying it here. Okay, so follow it like this. First you'll write quality, portability, as is utility and maintainability. As is utility means what? How well it can be used. Okay, observe carefully how well it can be used. First question, who is using it? A human is using it, means we people are using it. And when we use a product, it should be efficient. Okay, it should be efficient and reliable. Whenever we want to use, it should be available for the use, right? And it should be efficient, it should not consume more battery. Those three things you'll write here: human engineering, efficiency, and reliable. Done. After that, again come to the first point here: reliability. Reliability means what? Independence. Okay, reliable means independent, right? And self-containedness, this you cut and write self-reliant. Okay, reliability synonyms are independent, reliant, and self-reliant, accurate, complete, and integrated. Okay, these five keywords you'll be writing here. Done. After that, you will be coming to human engineering. Human means what? Communication, talking, always talking, right? Human means always talking, so communication. Okay, and human is consistent. Okay, if you want to reach your goal, you have to be consistent. Accountable, if you make any mistakes, be accountable for it. Efficiency, write it from here. And accessibility, humans they can access the devices. Okay, that in that way. Okay, so you'll be writing till communication for this one. Okay, reliability, efficiency, and human engineering. Portability, right here, and make the two arrows for the first two. The 2/3 of the diagram is done. Cool. The 1/3 is as easy as the 2/3. Then you will be writing maintainability. Maintainability, again three things already we discussed: testability, understandability, and modifiability. How we can test it and understand it and modify it. Again, start from the middle part. Okay, here also we start from the middle part, here also start from the middle part. Understandability. Understanding means what? Self descriptiveness. If I want to understand something, okay, if there is no user manual with that, we will not be able to understand that. So it should be self descriptive, and there should be a structure to it: concise, legible, augmentability. These things, whatever you want, you can write. Okay, just make sure that it is related to understandability. Testability, make some arrows here, random arrows. And modifiability, make a last arrow here to augmentability. In between arrows also make random arrows: first four here, second four here, third four here. No one will be seeing what arrows you make to which one. Okay, and based on that, marks will be getting. It is scientifically impossible that everyone will be looking for all the arrows here and checking it. Okay, so the key is you remember these key points here: portability, as is, utility, and manageability. Here we have three things: human is going to use a project, so it will be it should be efficient and reliable. Reliability, five synonyms: independent, self-reliant, accuracy, completeness, integrity. And human engineering, always talkative, so communication, and to reach the goal, consistent, and accountability for the errors, and efficiency from here, and accessibility from here. From this one, maintainability, testability, understandability, modifiability. Understandability, it should be self-descriptive, structure should be concise, legible. And from modifiability, augmentability. Testability, make some random arrows. Okay, and for the other ones also make random arrows. Okay, that was about the Boehm's model. Next is the Garvin's model. In Garvin's model, they can ask you a separate question like this also: what are the Garvin's quality dimensions? Okay, here what you have to write is there are 8 general attributes of the product. Some are measurable, some are not. Okay, they Garvin reasoned that sometimes user have subjective judgment of the quality of a program. The perceived quality means user is thinking that the quality is this. Okay, it must be taken into account to judge its quality. Okay, the user's perspective should be taken into account. The main thing, Garvin is very sympathetic because he's thinking from the user's perspective, and that should be also taken into account to judge its quality, the product's quality. Okay, so how we can do that? Divide the 8 general attributes. How many attributes are there in Garvin? 8 are there. How many are there? 8 are there in Garvin. Then divide into 3 parts. First is performance, feature, and reliability. This is some kind of uh, key indicator, right? Performance, feature, reliability. Does it sound similar to you? Performance, features, and reliability, right? So performance, how well it performs, and what are the features using which it performs, and how reliable it is. That is the first group. Second group is conformance, durability, and serviceability. You can understand these three are related and these three are related. Conformance means how much it requires meets the requirements. Durability means what is the product life. Serviceability means how its speed and effective it is. Last is the UI, which is aesthetics, the look and feel of the product, and perceived quality, how much the product quality the user's opinion is about. Okay, so these are all the questions. Don't miss any of these questions, and please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.